Okay, this is air pollution video 4. We're going to pick up where we left off on the last video on ventilation. We went through the last video on the different types of air pollution, what the pollutants are, and how their effect on humans. Remember, that was the video that I said to make sure that you summarize really clearly, because there's a lot of information in that. This one we can slow down a little bit more. There's a couple of big topics here. We're going to start with ventilation, and it's just the movement of air into and out of homes. So therefore, how much is available to dilute any potential pollutants that could be in the home or in the air outside the home. It serves as an indicator. So obviously, the less ventilation you have, the more likely it is that you would have some kind of contamination. You have indoor and outdoor air mixed by 3 ways: the infiltration, the natural ventilation, and the forced ventilation. So like infiltration is seeping in and around the cracks under the door. Natural ventilation would be opening a window, letting stuff through. And then forced ventilation is using something like an air humidifier, purifier, or a fan, or an air conditioning unit, something like that. So infiltration, exactly what I just went through and talked about. Natural air exchange, doors and windows are closed, leakage through holes and openings. It's pressure induced, so they're just moving inside and out based on pressure differentials. Natural ventilation, like I said, when you're opening doors to increase circulation, and then forced ventilation is the induction, is forcing the air movement. The trade-offs to the forced ventilation is that they cut the infiltration, or we want to cut infiltration because that decreases our heating and cooling costs. You know, we want a nice tight seal on windows and doors because that way we have to heat and cool less. But that leads to more air quality problems because there's less ventilation. So you want to hit that compromise where it's really healthy. The rate of infiltration is influenced by the speed of the wind, pressure differentials, temperature changes, and then the location where are the leaks. Okay, so how do we prevent air pollution? The traditional method is, moving the factory so that it's not around people. The taller the smokestack, that more wind picks up, so it moves it elsewhere and not just right over wherever you are. New technologies that we can have are the biofiltration, where we can have microbes degrade and use whatever pollutants or whatever chemicals we're spitting out. We can destroy through high voltage electricity, through membrane diffusion, and then through oxidation. Okay, so moving on to acid deposition, looking at acid rain. We use it measuring the pH scale. You guys are comfortable with pH, hopefully, at this point. That should just be a review from chemistry. Remember, the lower the pH, the more acidic it is. Neutral or pure water is 7.0 on the pH scale. Normal rain is about 5.6, slightly acidic. Anything less than 5.6 is defined as acid rain. Most of the acid rain in the U.S. in the year 2000 was about 4.3, so not necessarily hugely bad. Okay, so we can have a wet or a dry acid rain, 2 different types. The wet type refers to the actual precipitation, anything that's actually falling. For example, rain, fog, sleet, cloud vapor, snow that is acidic. And then the dry acid rain is like a fog, or like a gas or a particle that's released into the atmosphere that is acidic. Okay, so compounds. 2 main contributors, the sulfur dioxide and the nitrogen oxides. Both of those contribute to acid deposition. 66% of the sulfur and 25% of the nitrogen oxides are from electric power generators. By burning fossil fuels. So that's our biggest, fossil fuels is our biggest output right now in creating acid rain. Okay, so when they dissolve in rainwater, they make an acid. It's super simple. Don't make this more complicated than it has to be. The formation of acid rain is simply a regular rainfall with added pollutants like sulfur dioxide or nitrogen oxide that react with the H2O, with the rainfall, and turn into different acids depending on what type of pollutant you started with. So for example, if you have the sulfur dioxide in the water, that's going to make a sulfurous acid. You can have a carbonic acid, or you can have a nitrous or a nitric acid. So it just depends on what pollutant you start out with. Okay, so the causes of acid rain. Like I said, the sulfur and the nitrogen are the primary causes, and it's the fossil fuel. So that's just review. Okay, so just that's your basic cause of acid rain right now. Precipitation. This is showing how the acidic acid rain is formed. So you have those primary pollutants, and you have a few secondary that also might be contributing to this. They're coming from fossil fuels. They combine with the water in the atmosphere and form that acidic rainfall that can be toxic to plants, can leach into soils, so on and so forth. And that is the exact same diagram with color and a little bit different, so you can kind of picture it hopefully a little bit better from the emission source and then where it's going. Okay, so looking at the U.S., looking at the acid rainfall, notice that most of our acid rain is falling very close to where we see power plants going on, which becomes a whole lot more clear when you see the acid rain falling, downwind from the power plants here, the same up here, downwind from here, and then there are significantly more power plants in the U.S. On the eastern side of the U.S. So you see those trends following. The sulfur dioxide emission levels. Again, we see a whole lot more power plants in the eastern side of the U.S. and therefore higher sulfur dioxide emission. Okay, so the wet acid rain. The acidic water is obviously falling onto the ground. It affects a variety of plants and animals, so that's the most detrimental effect. And the dry is going back into the atmosphere and then back to the earth, so through that cycle. And you can get that onto buildings, cars, homes, trees, onto plants, so there would be the negative impact there more in the wind. You can wash it out of the plants, wash it out of other surfaces, the pavement or buildings or whatever the case may be, and then it's leached into the groundwater. So then that makes it even more acidic once it hits other pollutants in the like on all of our pavement or parking lots or anything like that. Okay, so the effects of acid rain depends on the strength of the acid rain. So how acidic the water is. If it falls onto a soil, is there any buffering capacity by the soil? Is that able to absorb any of that acid? And then what other things rely? What type of environment are you in? And what type of ecosystem are you in? And there's a variety of effects, really probably self-explanatory, or you guys would be able to guess most of them. Damage to forests and soils, to any living thing, including humans. Damage to materials, it wears stuff away, causes a lot of chemical erosion. We also see a lot of health factors for the living things, in increased cancer rates perhaps, or increased disease in animals as well. Reduction in visibility. You see a lot of the problem in aquatic environments where the pH is pretty high relatively, and then you end up with this acid rain that's making the pH drop significantly, and you have large fish kills. The plant life suffers, and therefore the whole food chain suffers. So that's where you see most of the effects of acid rain, is in the aquatic environments. So the buffering capacity, it's obviously going to affect, if there's a high buffering capacity, we'll see less of an effect from the acid rain because it's able to absorb that acid. But with the limited buffering capacity, we see a lot of the watersheds and the bodies of water are very sensitive to acid rain. So these pictures are right in the way. But so you can see the plankton life would drop down, plant life would drop down in a lot of these areas where the buffering capacity is low. The acid rain also releases aluminum from the soil, and then that's really toxic to a lot of the animals. So that causes additional fish kills, obstruction to the food chain. So we're looking, this table looks at the hydrogen ion concentration, so indirectly the pH, or actually really directly, sorry, hydroxide is indirectly. Hydrogen ion is direct to pH scale, so you can see what's going on. You see the highest, actually, unfortunately, up around Great Lakes are up here, so they're not right over the Great Lakes, but very close to, so that's a problem, or a lot of people are concerned by that. Okay, so the effects on wildlife, usually the younger individuals are more susceptible than the adults. At a pH of 5, you can't hatch fish. Lower pH levels, the adults can generally survive at a pH of 5, but if you go any lower, the adult fish die. So that's where I was talking about the fish kills come in, where we see significant mortality rates is in the aquatic environments. And again, the aluminum is toxic to fish. It doesn't necessarily have to be an immediate toxicity that would cause an immediate death, but we can see chronic cases where we see a chronic stress from increased aluminum or decreased pH. So you're not going to see the kills, but you're going to see maybe a lower body weight, smaller size. They're not going to be as strong. They're not going to be able to compete as well. So the food chain takes a hit. The biodiversity takes a hit. If the fish is not healthy, it won't reproduce as well. So we see problems there in reproduction, lower number of eggs. The eggs that they do lay may perhaps not survive, stuff like that. In forests, moving away from the aquatic environments, in forests, it doesn't usually kill the trees directly. Again, it's going to have that same chronic impact that we just talked about for the aquatic environments, where there's damage to the leaves. It blocks the nutrient uptake so that they're limited in what they can absorb and what they're exposed to, and then kind of has general decrease in overall health of the plant. So we see that in Mongolia and Germany after acid rains. They're not, the forest is still there, but definitely not healthy. And same here in North Carolina. Okay, so nutrients, the acidic water dissolves the nutrients and then washes them away before the trees can use them with that runoff. So rather than the nutrients being absorbed by the soil before that runoff gets to them, they're dissolved into the acidic rain and taken away, and then stuff like aluminum. They're really hitting that aluminum, so that aluminum is important, guys. Make sure that you guys know that release of aluminum is toxic to a lot of animals and plants. This looks at a human cause. I talked about the erosional effects. So a picture from 1908 to a picture of 1968. You see the same statue, but the erosional effect of the acid rain. Okay, so the results. Almost done. I feel like I've been doing nothing but giving you guys bad news all year with all, stuff that's really not in very good shape right now. We're actually doing very well with air pollution control, especially in the U.S. There's still areas that we can work on. It's still not a perfect science. The dependence on fossil fuels still puts out a lot of pollutants into the atmosphere. However, overall, compared to a lot of other problems we have, this is doing better. We're making significant standards to improve this. And I think one of the reasons, in my personal opinion, is that there's so much that affects the human health with this, that this is something that people dealt with right away. So we see overall emissions dropping right around 1960, 1970, when people started to be aware. We see emissions going down for the most part. Not quite as much. We still need to work on the nitrogen oxides, but overall doing better. Comparing, we same concept, just different format. We see the emissions dropping overall for all of these. The only one that's going up slightly is the nitrogen oxides. Everything else, emissions are decreasing. Percent change, same concept. You're seeing trends. So the way to read this, between 1980 and 1999, carbon monoxide dropped 22 points, 22%. In 1990 to 1999, it dropped a further 7%. Nitrogen oxide was going up 1. These are dropping significantly. Significant drop. So we're seeing good drops for all of these pollutants. Okay, so comparing, the emissions, this is what I was talking about. From 1970 to 2000, we see the emissions decrease 31%, which is awesome. And we're doing that even though the population increased 33%, and the stuff that we are using, the resources that we're using, increased by 100 and almost 150% for both cases. So we really are working hard to keep the air pollution under control. Same graph. Okay, so the sulfur dioxide emissions after the acid rain program. So we see it from 80 to 90 to almost 2,000. We see significant drops in emissions, which is really good. We see a whole lot more of the yellow to gray as opposed to the dark red that we saw there. So that's a